over the exam 3 review for 0324 or 1314. I mean 1324. Okay, the exam review consists of the following topics, which is chapter 6. 6.1, systems of two linear equations and two variables. 6.2, larger systems of linear equations. 6.3, applications of systems of linear equations. 6.4, basic matrix operations. 6.5, matrix products and inverses. And section 6.6 is application of matrices. So let's begin with a section from 6.1. This is number 1 and number 2. It says determine whether the given order list of numbers is a solution of the systems of equations. So number 1 is a point -1, 3. If it's a solution for equations 1 and equation 2, right? So this is equation 1 and 2. So I'm going to plug in -1 for x and 3 for y. So my x is -1, my y is 3. So it's going to give us -2 plus 3 on the left side. So 1 equals to 1. That means that this point belongs to the first equation. But in order for it to be like the solution of both equations, it has to be true for both equations, not only one of them. So once it's true for equation 1, then we can proceed for equation 2. Okay, we're going to do the same thing. We're going to plug in -1 for x and 3 for y. On the left side, it's going to give us 3 plus 6, which will give us 9. So 9 equals to 9. So that means that -1, 3 is the solution of the equations 1 and 2. Okay. Now let's repeat the process for number 2. But the process is two different equations and also a different point, which is 2, -0.5. So let's repeat the process as number 1. We're going to plug in 2 for the x and -0.5 for the y. Right? It gives us 1 minus 4. It's going to give us -3 equals to -3, right? So this is true. So then we can proceed to equation number 2. Again, we're going to plug in 2 for x and -0.5 for y. The result will be 2 minus 2.5 will give us -0.5 equals to -5. No, it doesn't. That's not true. Therefore, the order 2 -0.5 does not make both equations true. Then the order pair is not a solution. So number 1 was a solution and number 2 is not a solution. Now, you can solve systems of equations by graphing, by substitution, and by the elimination method. So I'm going to show you all 3. Okay, now, by graphing, we know that my slope is 3, 1, right? Which means, which means it's going to go up 3 and 1 across from the starting point, which is -6. So we're going to start at 0, -6, which will be down here at the bottom. Now, the rise over the run is going to be 3 up, 1, 2, 3, and 1 to the right. Right? And then we connect the 2 points, and that's my line. Now, we do the same thing for number 2. Okay, equation 2. But equation 2 is not in proper form, right? It's not in the y equals to mx plus b form. So we have to rewrite it in proper form. So we're going to add 5x to both sides because we're solving for y. It's going to give us -2y equals to 5x minus 10. Then we divide every term by -2. The result will be y equals to -5/2x plus 5. My slope is -5/2, and my b, which is a y-intercept, will be 0.5. 0.5, the b is always your starting point. So I'm going to start at 0.5 for the y. Now the slope is -5/2, which means I'm going to go down 5 and 2 to the right from the starting point, which is 0.5. So if we go down 5, let's see, 1, 2, 3, 4, 5, and 2 to the right will be right there at the point 2, 0. We connect the 2 points, And the answer or the solution is where the both lines intersect, which will be 2, 0. So the solution will be 2, 0. Okay, that's how we solve by graphing. Now we're going to do the very same problem, but we're going to do it another way, by substitution. Okay, so again, the first equation, let's call it equation 1, and the second equation, let's call it, equation 2. Okay, the objective here is to try to isolate one of the variables. For example, in equation 1, the y is already by itself, right? Or it's already isolated. So what I'm going to do, I'm going to go to equation 2. I'm going to plug in 3x minus 6 where the y is, because y equals to 3x minus 6. Okay, so I'm going to plug 3x minus 6 where the y is, and I use color code. That way you guys can see what we're doing here, and it's better to do it in color. The color coding. There's my y, 3x minus 6. Now I'm going to distribute. It's going to give us a negative 5x minus 6x plus 12, right? Because negative 2 times 3x will give us negative 6x. Negative 2 times negative 6 will give us a positive 12. Equals to negative 10 on the right side. So my first step here, I'm going to combine terms, right? So the negative 5x minus the 6x are like terms, so we can combine them. So it's going to give us negative 11x plus 12 equals to negative 10. My next step, I need to isolate the x, right? So we have to do two steps before we do that. So the first step is we subtract 12 to both sides. They'll give us negative 11x equals to negative 22 because negative 12 on the left side, the 12 minus 12 is 0. And negative 10 minus 12 will give us negative 22. Now the final step is to divide both sides by negative 11. So the result will give us x equals to 2. So I got my x value. Now I need my y value because a point has an x value and a y value, another pair. So now I can go back to either equations 1 or 2, whatever is easier for you. In my opinion, it's easier to go to equation 1 because the y is already by itself or it's already isolated. So I'm going to plug in 2 where the x is. That's going to give us 6 minus 6. The answer will be 0. You see, we got the same solution as when we graphed it by graphing, when we saw it by graphing, right? The answer was 2, 0. That's how you can do it by substitution. Now let's do one by the elimination method. Okay, I should have done the same one as before, right? But we should have gone the same thing 2, 0. But this is another example. In order to solve by elimination method, they have to be in the form ax plus by equals 0. Okay, but equation 1 is not in proper form. Ax plus by equals 0, right? So I need to rewrite equation 1. So I'm gonna add 2y to both sides. So it's going to give us x plus 2y equals 19. Now it's in proper form in the form of ax plus by equals c. Now here, guys, you have to eliminate either the x's or the y's. It doesn't matter. Like I always tell my students, whatever is easier for you guys. Okay, here, in my opinion, I will do this because I think it's easier. I'm going to eliminate the x's. Why the x's? Because the x on equation 1, there's like a 1 there. So if I multiply negative 4 by times equation 1, it's going to give us a negative 4x, and then they're going to be eliminated. If I want to cancel the y's, right, then I have to multiply 3 by equation 1 and 2 by equation 2. That's too much work. So again, what's easier for you, I think what's easier will be to eliminate the x's. So I'm going to eliminate the x's by multiplying equation 1 by negative 4. But in math, you have to do the proper steps or procedures. What you do to the left side, you also do to the right side. So I need to multiply negative 4 times every term, or both sides of the equal sign. Negative 4 times x will give us negative 4x. Negative 4 times 2y will give us negative 8y. and negative 4 times 19 will give us negative 76. So equation 2, all we do is slide it over. Right, same thing. Now we add them. You see the x's are eliminated because negative 4x plus 4x will give us a 0x. We combine the y's. It's going to give us negative 11y equals to negative 77. Now we divide both sides by negative 11. And the result will be y equals to 7. Right? Now I need to find the x value. So I can go either to equations 1 or equations 2. In my opinion, it's easier to go to equation 1 because equation 1 is already, the x is already by itself, or the x is already isolated. Okay? So I'm going to go to equation 1. I'm going to plug in 7 where the y is. That'll give us x equals to negative 14 plus 19, which means x equals to 5. So my solution is 5, 7. That's your solution. And recall, guys, the first slide that I went over. If an order pairs a solution, right, you can also check. I'm going to, if you want, you could plug in 5 and 7 to both equations, 1 and 2. And you're going to find out that you're going to get, I mean, it's going to be true what's on the left side is going to be on the right side. So, for example, if I plug in the 5 and the 7 here in equation 1, it's going to give us 19. If I plug in 5 and 7 on equation 2, it's going to give us negative 1. Okay, that's why the first slide, or number 1 and number 2 on this review, that's why you can always check the work. Okay, but I know this is correct. Now let's do another one. Okay, here, guys, again, let's eliminate the excess. So I'm going to multiply equation 1 by negative 2. You might be asking, why negative 2? Because negative 2 times 3x will give us negative 6x. And if when I add them, the x's will be eliminated. Okay. Negative 2 times 3x will give us negative 6x. Negative 2 times negative 2y will give us a positive 4y. And negative 2 times 4 will give us a negative 8. If you notice, we're going to get 0 equals to 0. What does that mean? That means that there's infinite solutions. Okay, when you're solving systems, it can either be 3 different answers. 3 different ways it can be the answer. The first way is one solution, what we've been doing. When you get something like 0 equals to 0, that means there's going to be infinite solutions. And you get something like a number equals to 0 equals to a number that's not true on both sides, there'll be no solution. That means the lines are parallel. In this case, it means that the line is on top of another line, which will be our real numbers. Infinite solutions. Now let's do one with no solution. Okay, let's multiply again negative 3 by equation 1. So that's going to give us negative 6x minus 15y equals to negative 24. We slide over equation 2. When we add them, it's going to give us 0 equals to negative 6, right? That's not true, which means no solution. It means the lines will never intersect. Okay, it means the lines are parallel. Now, how do you apply solving systems of linear equations to real life situation? This is a good example. Okay, number 8. It says a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? Okay, so here it is. A lot of students, they don't like word problems, okay, but they're not that bad. Okay, you have to get the info and you have to make 2 equations. Okay, like I tell my students, you're going to do seats with seats and money with money. What do I mean by seats with seats? Okay, there's a 200-seat theater, right? The theater consists of adults and children. So since adults is first, I'm going to let x equals to adults and adult seats, and y equals to children seats. You see, here it is: seats with seats, adult seats plus children seats equals to 200. So that's equation number 1. X plus y equals 200. Now we're going to do money with money. Okay, let's see here. It's $8 for adults, right? and adult tickets is represented by X, so it's going to give us 8X. Children's tickets are $5, right? So since children's seats is Y, this is going to give us 5Y. And the total money or the total income is $1,435. So here's my second equation. 8X plus 5Y equals to 1,435. Now I have both equations, 1 and 2. Now you can solve it by graphing, which I don't recommend. You can solve it by substitution, which it's okay. But I prefer to solve it by the elimination method because it's already set up in the proper form. Okay? So again, you decide how you want to solve it. But I'm going to use the easy route. I mean for me, right? Anyway, I'm going to get rid of the x's. So to get rid of the x's, I'm going to multiply equation 1 by -8. Why? Because -8 times x will give us -8x. Then when I add 8x to it, they'll be eliminated. But I need to multiply -8 times every term in the equation. It's going to give us -8x minus 8y equals to -1600. Because -8 times 200 will give us a -1600. And -8 times y will give us -8y. And -8 times x will give us -8x. Equation 2, I will do is bring it over. Now we add them. If you notice, the x's were eliminated. So -8y plus 5y will give us -3y. And -1600 plus 1,435 will give us -165. We divide both sides by -11. I mean by -3. I'm sorry about that. So y equals to 55. Okay. So then we need to plug in 55 for y in either equations 1 or 2. What's easier, guys, is equation 1 because the x and the y are there's no coefficient. The coefficient is 1, which will make it much easier. So my y is 55. Plug in 55. So then we subtract 55 from both sides. So x equals to 145. So the answer is x equals to 145 and y equals to 55, but that's not what they're asking. They're asking how many adults and how many children were in the audience. A lot of students, when I give an exam, they stop here and I take partial credit off, right? Because that's not what they're asking for. What they're asking for is how many children and how many adults. So since x is adults, so the x means it's going to be 145 adults, and the y is children is going to be 55 children. So my answer will be 145 adults and 55 children. Now, this is the 6.2 portion of the exam, of the exam review. These are called larger systems of linear equations, which means it's going to be 3 equations. Let's call it 1, 2, and 3. Okay, now here's a plan. If you follow this plan, guys, you can never go wrong. What we're going to do, we're going to take equations 1 and 2 and eliminate the x's. Then we're going to get equations 1 and 3 and also eliminate the x's. I believe 2 weeks ago is when this PowerPoint was covered. The section. And I believe because I couldn't come that day, Mr. Carrizales covered it for me. But the plan is from the workshop of 2 weeks ago. Okay, I'm going to show you the plan and everything. But here I'm going to follow the plan, which means, right, I need to eliminate the x's in equation 1 and 2. So I'm going to multiply -2 times equation 1. Right? If I multiply -2 times every term, it will give us -2x plus 6y minus 4z equals to 0. So equation 2, we'll just bring it over. You see, guys, the x's were eliminated. So this is my new equation 2. Now I repeat the process, but I'm going to do 1 and 3. And the same process, which means I have to get rid of the x's. So I'm going to multiply -3 by equation 1. it gives us negative 3x plus 9y minus 6z equals to 0. Equation 3, we just bring it over. And if you notice, the x's got eliminated. So this is the new equation 3. Now, the next step in the plan is I'm going to get the new equation 2 and the new equation 3, and I'm going to eliminate the y's. Okay? Now here most instructors and also the textbook will say, what's the least common multiple between 10 and 4? The answer is 20, right? But to me, guys, I don't want you guys to do too many steps. For example, I always tell my students, don't worry about the least common multiple, which means the lowest number that both 4 and 10 can go into. I know it's 20, but you don't have to do it that way. What you can do here, you're going to multiply equation 2 by negative 10, and equation 3 by 4. Why? Because what's here, the coefficient that's in equation 3, you're going to multiply by equation 2, and the coefficient in equation 2, you're going to multiply by equation 3. But since both are positive, I have to multiply one by a negative. So I'm going to multiply this one by negative 10. Now I'm going to multiply negative 10 times every term. And I'm going to multiply 4 by every term in equation number 3. So negative 10 times 4 will give us negative 40y. Negative 10 times negative 3z will give us positive 30z. Negative 10 times 3 will give us negative 30. 4 times 10y will give us 40y. 4 times negative 7z will give us negative 28z. And 4 times 7 will give us positive 28. Now, if we add them, you've noticed the y's got eliminated. So 30z minus 28z will give us 2z. And negative 30 plus 28 will give us negative 2. Now I divide both sides by 2. So z equals to negative 1. I got my z. Now I need to solve for x and for y. Right? So if you want, right, I have equation 1. On equation 2, right, I got equation 2, and this is my new equation 3, which would be z equals to negative 1. Now I'm going to back substitute. Okay, which means I'm going to go back to equation 2. I'm going to plug in the negative 1 for z and solve for y. Subtract 3 from both sides. It's going to give us 4y equals to 0. Divide both sides by 4. It's going to give us 0. So my y is 0 and my z is negative 1. Now I go back to equation number 1, and I'm going to plug in 0 for y and negative 1 for z. So my y is 0, plug in 0 there, and my z is negative 1, plug in negative 1. So I'm going to get x minus 2 equals 0. I add 2 to both sides, so x equals to 2. So I solve the system, which is 2, 0, negative 1. That's my solution. Okay, now, this is the Gauss-Jordan elimination method. I think this is one of the hardest problems or to do, guys, in this chapter here. And the Gauss-Jordan method is crucial if you're taking the next math course. I believe it's in chapter 7. In chapter 7, it's up to the, I think it's optional. For the instructor to explain. And most of the times when I teach at 1325, I don't cover this section because it's optional. But if you go to UTEP or NMSU, they cover it there. That's why solving the Gauss-Jordan method is really important if you're taking the next math course. It's also explained in the 1314 math. And this method, guys, is very crucial for engineers and also for math teachers. So it's good to know this method. Okay, now I came up with a system, guys. Okay, if you follow the system that I modified, it's not that complicated. Okay. Okay, now you're going to start with linear systems of equations. Then you're going to put it in augmented form, the matrix, and then it's going to be in RREF, which means reduced row echelon form. Okay, I'm going to show you an example of what each one of these means. You see, this is a linear system of equations, right? This is called the linear system of equations. Augmenting matrix means you're going to convert it into a matrix. I'm going to get the coefficients. For example, this is 1, -3, 2, 0. That's row 1. Then 2, -2, 1, and 3. And then finally 3, 1, -1, and 7. This is called the augmenting matrix. Now, the reduced row echelon form means that all the ones from the corner to the bottom have to be ones. Diagonal, and the rest are zeros. And then this will be your solution: x equals to 2, y equals to 0, and z equals to -1. I believe this is the same one that we did previously, right? So you can do it two ways, but it's good to know how to do it by using the Gauss-Jordan method. How do you go from linear systems to the matrix solve reduced row echelon form? Here's how. I call it the 3-step plan in action. Now, so step 1, right? Step 1, if you notice what's in blue here on the right is step 1, the green is step 2, and the red is step 3. So every step has possible parts A and parts B. Okay, I'm going to call it this row 1, row 2, and row 3. Okay, now, so step 1, row 1 stays the same. So I have to eliminate the 2 in column 1 and row 2, and the 3 in column 1, row 3. So that's why I put a blue there, right? I put it in blue because it's step 1. I need to eliminate that 2, which means I need to use row 1 to eliminate row 2. So here, guys, I'm going to multiply. Okay, here, I'll show you right now. I'm going to multiply -2 times row 1 and add it to row 2. I'm going to multiply -3 times row 1 and add it to row 3. And here's my work. -2 row 1 equals to -2 times row 1, which is 1, -3, 2, and 0. Right, if I multiply -2 times 1 will give us -2. -2 times 3, -3 will give us +6. -2 times +2 will give us -4. And -2 times 0 will give us 0. Now, plus row 2, right? So I'm doing what's here in the step here. So row 2, I just bring it over. I add them. So I get 0, 4, -3, 3. So this is my new. Now I'm going to do the second part of step 1, which is -3 row 1, -3 times row 1 is going to give us -3, 9, -6, and 0. Plus row 3, so row 3, we'll just bring it over. Right, now we add them. It's going to give us 0, 10, -7, 7. That's my new row 3. So step 1 is done. Now on the next slide, I'm going to continue and do step 2. So this is what we got, the answer for step 2, right? So we're done with step 1. Now step 2 is going to be in green. Remember the objective. Is step 2 eliminate. So where the -3 is, so step 2, I'm going to keep row 2. So the -3 must be a 0. So row 1's got to change. And the 10 has to be a 0. So row 3's got to change. Okay, I'm going to be using row 2, right? So to get rid of the 3, I'm going to multiply 3 times row 2 and add it to 4 times row 1. Because 3 times 4 will give us 12, and -3 times 4 will give us -12, and then they'll be eliminated. And also, guys, on the where the 10 is, right, I need to multiply -10 times the 4, times the row 2, and 4 times row 3. This way, the 10 will be eliminated. And here's the work. 3 times 0 will give us 0. 3 times -3, 3 times 4 will give us 12. 3 times negative 3 will give us negative 9. And 3 times 3 will give us 9. Now, 4 times 1 will give us 4. 4 times negative 3 will give us negative 12. 4 times 2 will give us 8. And 4 times 0 will give us 0. Now, we add them. So it's 4, 0, negative 1, 9. So that's my new row 1. Now, I'm going to do the second step. Part B of step 2. Negative 10 times row 2 will give us negative 10 times 0 will give us 0. Right? Negative 10 times 4 will give us negative 40. Negative 10 times negative 3 will give us 30. And negative 10 times positive 3 will give us negative 30. In similar fashion, right, if I multiply 4 times all the terms there, it's going to give us 0, 40, negative 28, and 28. If we add them, we get 0, 0, 2, negative 2. So here, guys, I'm going to simplify. This can be simplified. So I'm going to divide everything by 2. If I do that, it's going to give us 0, 0, 1, negative 1. So this is my new row 3. You see, guys, I'm done with step 1, which these two are zeros. I'm done with step 2, which these two are zeros. Now I need step 3. So step 3, I'm going to go on the next slide, and it's going to be color-coded with red. So step 3, I'm going to keep row 3. So where the negative 1 is, must be a 0. Where the negative 3 is, must be a 0. So row 1's got to change. And where the negative 3 is, got to be a 0. So row 2's got to change. So I'll be using row 3. So if you notice, if I add 1 plus negative 1, it's going to give me a 0. So it's going to be row 3 plus row 1. Here, right, I need to multiply 3 times row 3 and add it to row 2, because 3 times 1 will give us 3, and 3 plus negative 3 will give us a 0 where the negative 3 is. Here's my work. Right, we just add row 3 and row 1. It's going to give us 4, 0, 0, 8. And this can be simplified. Hey guys, if you simplify, you're going to get only 3 steps. And if you don't, it's going to be a little bit more harder to do, and then it's going to be more matrices or more steps. So divide everything by 4. So row 1 becomes 1, 0, 0, 2. Now I'm going to multiply 3 times row 3. So 3 times 0, 3 times 0, 3 times 1, and 3 times negative 1 will give us 0, 0, 3, negative 3. Plus, right, row 2. And then if we add them, it's going to give us 0, 4, 0, 0. And again, we can simplify because this has to be a 1, right? It's got to be a 1 there. So divide everything by 4. It's going to give us 0, 1, 0, 0. That's my new row 2. If you notice, it's already solved because all the diagonals are 1s. The rest are zeros. We got 2, 0, negative 1. Hey guys, the first column are the x's. The second column are my y's. The third column are my z's. So here means 1x plus 0y plus 0z equals to 2. In other words, x equals to 2. On the second row, it means y equals to 0. On the third row, means z equals to negative 1. So the solution will be 2, 0, negative 1. Okay, now let's do another one here. Okay, so step 1, we keep row 1. So we're going to change row 2, and we're going to change row 3. So I'm going to multiply negative 2 times row 1 and add it to row 2. Then I'm going to just add row 1 plus row 3. And this way, where the 2 and the negative 1s are, they're going to become zeros. And here's my work. Right, so negative 2 row 1 plus row 2. All we do is bring row 2 down. Right, and that's row 2, the 2, negative 1, 3, 2. We add them, it's going to give us 0, negative 5, 5, negative 10. And here, guys, we can simplify. We divide everything by negative 1, by negative 5, it's going to give us 0, 1, negative 1, and 2. That's my new row 2. Now we're going to add row 1 plus row 3. We add them, it's going to give us 0, 1, 0, 1. That's my new row 3. Now, step 2, right? We're going to keep row 2. So the 2 in row 1 is going to change, and the 1 in row 3 is going to change. So here, guys, I'm going to multiply -2 times row 2 and add it to row 1. And here I'm going to multiply -1 times row 2 and add it to row 3. And here's my work. So -2 row 2 will give us -2 times 0 times 1 times -1 times 2 is going to give us 0, -2, 2, and -4. Plus row 1. Row 1, we just bring it over. After we add them, we're going to get 1, 0, 1, 2. That's my new row 1. We're going to multiply -1 times row 2 is going to give us 0, -1, 1, and -2. We're going to add it to row 3. So it's going to give us 0, 0, 1, and -1. That's my new row 3. Now finally, right, step 3, where the 1 is in row 1, right? Row 1, column 3 is going to change. So row 1 is going to change, and row 2 is going to change. We're going to be using row 3. So since third column in row 1 is a 1, and the third column in row 3 is a 1, so I can multiply -1 times row 3 and add it to row 1. And here, guys, for row 2 is right, row 2 third column, so we can just add these two, and it's going to cancel the -1. So it's going to be row 3 plus row 2. So -1 row 3 will give us 0, 0, -1, and 1. Plus row 1 will give us, after we add them, it's going to give us 1, 0, 0, 3. That's my new row 1. Then we're going to add row 3 plus row 2. Right after we add them, it's going to give us 0, 1, 0, 1. That's my new row 2. So that means that x equals to 3, y equals to 1, and z equals to -1. So that's my solution, will be 3, 1, -1. Okay, now how do we apply three solving systems of three-linear equations into a real applications problem? And here it is. Here's an example. It says tickets to a band concert cost $4 for adults, $3 for teenagers, and $2 for preteens. There were 570 people at the concert. The total ticket receipts were $1,950. 3/4 as many teenagers as preteens attended. How many adults, teenagers, and preteens attended the concert? Okay. Again, it's going to be like before. It's going to be people with people, or seats with seats, and money with money. The third equation is always like the hardest one to get. Okay, but I'm going to show you how to get it. So we're going to let x equals to adults, y equals to teenagers, and z equals to preteens. And the total people at the concert were 570, so it's going to be x plus y plus z equals to 570. No money with money, right? So it was $5 for adults, right? So since x is adults, so it's going to be 5x. $3 for teenagers, and since y represents teenagers, it's going to be 3y. And finally, $2 for the preteens, and since z represents preteens, it's going to be 2z. And the total money or receipts was $1,950. So there's my second equation: 5x plus 3y plus 2z equals to 1950. Now we need equation number 3. Okay, how do we get that? Because the second to the last sentence gives us a key for equation number 3. 3/4 as many teenagers. It says 3/4 as many teenagers as preteens attended. Okay, here, guys, this is kind of a little bit challenging, right? But write it how it sounds, and then change or flip it. Okay, let me see if we can come up with another word. Hey guys, but okay, this is the solution, guys. Okay, y equals to 3, 4, z. But that's the reason why I say, well, how on the road did you get that? Okay, if it is difficult, write it how it sounds and then switch it. It sounds right, since the teenagers is y, it sounds like 3/4 y equals to z, to the preteens, right? That's the way it sounds. And then you switch it. You switch the 3/4, you put it for the z is, for the preteens. And that's how you set it up. And I believe, guys, this will work every time. So I got my third equation, guys, right? But first of all, remember, guys, it's going to be in proper form. It's going to be x plus y plus z equals to a constant, or ax plus by plus cz equals to d. So I need to multiply 4 to both sides. And then I'm going to subtract 3z from both sides. It's going to give us 4y minus 3z equals to 0. And that's equation number 3. Okay, those are my 3 equations. Right now, you can solve it by matrices, or you can solve it by, also, guys, this can also be plugged in the calculator. Okay, I don't know if I will be able to show you here, guys, on the screen, but let's do it how we did it with from before, right? Remember, we're going to get equations 1 and 2, get rid of the x's, 1 and 3, and get rid of the x's, right? Remember that? So let's do it that way because it's easier. So I'm going to multiply equation 1 by -5. Right, if we multiply -5 times x times y times z times 570 will give us -5x minus 5y minus 5z equals to -2,150. So equation 2, we'll just bring it over. Right, so we have -2y minus 3z equals to -900. So that's my new equation 2. If you notice, equation 3 has no x term, so we don't have to do that step. So we'll do the new equation 2 plus the equation 3. Now here, guys, I'm going to get rid of the y's, right? So equation 2, I'm going to multiply by 2. Why 2? Because -2 times 2 will give us -4. -4y, -4y plus 4y will give us 0. They'll be eliminated. Okay, so multiplying 2 times every term on equation 2 gives us -4y minus 6z equals to -1800. Right, after we add them, we get -9z equals to -1800. We divide both sides by -9, and it gives us z equals to 200. Now we can go back and back substitute. So I'm going to go to my new equation 2, and I'm going to plug in 200 for z. This gives us -2y minus 600 equals to -900. We add 600 to both sides. So it's going to give us -2y equals to -300. We divide by -2. It'll give us y equals to 150. Now I'm going to go to equation 1 to finally solve for x, right? We know what the y is and we know what the z is. So I'm going to plug in 150 for y and 200 for z. Right? We subtract 350 from both sides. So x equals to 220. So the answer is 220, 150, and 200, right? But so these are my answers. But remember, x was adults, teenagers was y, and preteens was z. So it's going to be 220 adults, 150 teenagers, and 200 preteens in the concert. Now comes section 6.4. Right? We're gonna, I think we're gonna add these. So this is a size for A, for B, and for C, and for D. So A plus B, right? So I'm going to add the 5 and the 2, the -1 and the 0, and the 6 and the 1, the 3 plus the -3, the 4 plus the 1, the -2 plus the 4. So it's going to give us 7, -1, 7, 0, 5, and 2. That's my answer. Can I do C plus D? Remember, guys, to add them or subtract them, they have to be the same size. So C and D are both 2 by 2 matrices, which means it can be done. So it'll be 3 plus 2, 1 plus -1, negative 5 plus 8, 0 plus negative 6. So it's going to give us 5, 0, 3, and negative 6. That's my solution of C plus D. Can I do C plus A? C is 2 by 2, A is 2 by 3. A cannot be done because not the same size. Okay. Now same thing with subtraction. Okay. So it'll be 1 minus 8, negative 3 minus 0, 2 minus 1, 2 minus negative 1, 2 minus 3, and negative 1 minus 4. So it's going to give us negative 7, negative 3, positive 1, positive 3, negative 1, and negative 5. Same thing with C minus D, right? So it'll be 5 minus 2, 1 minus negative 1, negative 4 minus 9, 3 minus negative 7. So the result will be 3, 2, negative 13, and positive 10. That's my solution. Can I do A minus C? You can because they're not the same size. My A is 2 by 3, my C is 2 by 2, so A cannot be done. Not possible. Okay, now let's do negative 4A and 5B for B, and negative 4A plus 5B. In other words, all this is setting up for C, which is negative 4A plus 5B. So first, let's do negative 4A. Negative 4 times A means negative 4 times matrix A. It means that I'm going to multiply negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. If you want, guys, you don't have to do this step here. I'm just showing you so you guys can see what's taking place, but you can go straight from here, guys, from negative 4 times matrix A. You can just say negative 4 times negative 2 will give us 8. Negative 4 times 0 will give us 0. Negative 4 times 5 will give us negative 20. And negative 4 times 3 will give us negative 12. So the answer for negative 4A is 8, 0, negative 20, negative 12. Now 5B is 5 times everything in matrix B. It'll be 5 times 0, 5 times 2, 5 times 4, 5 times negative 6. So it's going to give us 0, 10, 20, negative 30. Now for part C, right, we're going to add negative 4A plus 5B. So negative 4A, right, we did it here on the A part. Plus 5B, we did it on B part, which is in red, right? Now we're going to add them. It's going to be 8 plus 0, 0 plus 10, negative 20 plus 20, and negative 12 plus negative 30. And my result will be 8, 10, 0, and negative 42. That's my answer. Okay, now comes the multiplication part. Okay, so for multiplication, there's a rule that's got to take place. The two numbers in the middle must match. So for example, matrix B times matrix A, B is a 2 by 2 and A is a 2 by 3, right? So since the two in the middle numbers match, yes, it can be done. And the answer will be a 2 by 3, right? So let's do this. So this is like a few steps. So step 1, again, I'm going to use color-coded. That way you guys can see what's taking place. So matrix B is 1, 0, 4, negative 2. And matrix A is 2, 0, 5, 4, negative 2, negative 3. So the objective here is that I'm going to multiply the first row times the first column for the first part, the first row times the second column, the first row times the third column. And then we're going to multiply the second row times every column as what we just did. Okay, so let's do it. So it's going to be 1 times 2 plus 0 times 4. It's going to give us 2. So that 2 goes on the first slot, which is row 1, column 1. Now for step 2, right? I'm going to multiply the same row, but now times the second column. So it'll be 1 times 0 and 0 times -2. It's going to give us 0 plus 0. The answer is 0. So the 0 goes on the first row, second column. Now we're going to multiply the first row times the third column. Right, and also we use color code. So it'll be 1 times 5 plus 0 times -3. The answer will be 5 plus 0. The answer is 5. So the 5 goes on the first row, third column. Now, since we're done, right, since we're done with multiplying the first row times every column, now comes row 2. And we're going to repeat the process as what we did in step 1. So it'll be row 2 times column 1. So 4 times 2 plus -2 times 4 will give us 8 minus 8 will give us 0. So the 0 goes on the second row, first column. Now step 5, we're going to multiply the second row times the second column. So 4 times 0 plus -2 times -2. That's going to give us 0 plus 4. The answer will be 4. So the 4 goes on the second row, second column. Now finally, we're going to multiply the second row times the third column. So 4 times 5 will give us 20. -2 times -3 will give us 6. So 20 plus 6 will give us 26. And that goes on the second row, third column. So that's my solution. That's your answer, guys. Okay. Now let's find the inverse by using the formula. Now here, guys, we'll do it the long way. Okay. We use the Gauss-Jordan method. If it's a 2 by 2 matrix, to find the inverse, you can do it this way by the Gauss-Jordan method, or there's a specific formula for a 2 by 2 matrix. So first, let's do it this way. So this is my inverse here, guys, -3, 1, 2, -1/2. But how do we get it? That's right. So here's how. So again, by using the Gauss-Jordan method, right? So for the 4th, that's going to be a 0. So I'm going to multiply -4 times row 1 and add it to row 2. And the answer, we're going to keep row 1. And here's my work. -4 times row 1 will give us -4, -8, -4, and 0. Plus row 1, plus row 2, I'm sorry. We bring in the row 2 down, so it's going to give us 0, -2, -4, and 1. That's my new row 2. Now, on the first row, right, where the 2 is, that's going to be a 0. So row 1 is going to change, and row 2 stays the same. So if we just add them, that will give me a 0 where the first row is, second column is, the entry 2 is. So we just add row 2 plus row 1. It's going to give us 1, 0, -1, 3. Right? But this has to be a 1, right? Remember, this has to be a 1 here, where the -2 is. So I'm going to multiply -1/2 times row 2. So after I do that, it's going to give us 0, 1, 2, and -1/2. You see, this is my inverse, guys. That's how you get the inverse. Okay. Now, this is by using the formula. The inverse will be 1 over A times D minus B times C. And then the A and the D, you switch them. And then the B and the C become the opposite signs. So there's a formula to find the inverse of a 2 by 2 matrix. That way you don't have to do it by using the Gauss-Jordan method. Okay, that's a matrix. So the inverse will be, right, it will be 1 over 1 times 6 minus 2 times 4, right, by following the formula there. And then the 1 switch places. And the 2 and the 4 becomes the opposite sign. So it becomes -2 and -4. If you notice, at the bottom we have 1 over 6 minus 8 will give us -1/2. So it'll be -1/2 times every entry on the matrix here to the right. So it's going to give us -1/2 times 6, -1/2 times -2, -1/2 times -4, and -1/2 times 1 will give us -3, 1, 2, and -1/2. So this is my inverse. Okay. Okay, now here's how you plug in the calculator. You're going to hit second matrix, right? It's where the inverse key is. Then you're going to go to edit. Then you're going to enter. Now you're going to enter the size of the matrix. After you do that, right, there's going to be second quit. After you do all that step, you go to second quit, and the screen should be blank. That's the key that you hit. Now, if solving the system, then you're going to go to second matrix. You're going to go down to math. Then you're going to go to RREF and enter, and then you go get the matrix. Choose the matrix being solved, and then that's the answer. If, right, and then you close parentheses to get the answer. But if you want to add subtract matrices, all you do is enter the matrices, each one on the matrix A, B, and C, and then do the operation to get the answer. You see, for this is for solving, right? But if you want to store the matrix in the calculator, right, you stop here, and then you repeat the process and enter all the matrices, and then you can do the operation. Okay. Now, I think this is the last one. Let me see what time it is. It's already 12. Let's see here, guys. So solve the matrix equation by using AX equals to B. Solution, right? So X equals to A inverse times B. Need to find the inverse of matrix A and multiply by matrix B. So using the inverse formula, right? If you use the inverse formula, right, there's a formula. This is what you should see, guys, for the inverse. Okay, but using the formula. I mean, you guys can practice that. Then, to solve for X, I'm going to multiply the inverse times matrix B. Right? This is a 2 by 2 matrix. This is a 2 by 1, so it can be done. So the answer will be a 2 by 1 matrix. Yes, that'll be the answer, 2 by 1. And if you do the work, guys, this is what the answer should be. Because we multiply 5/3. Let me see here. I'm going to multiply, right, the first row times, it'll be 5/3 times -3 will give us -15/3. -2/3, and then plus, right, -2/3 plus, let me see, -2/3 times 5 will give us -10/3. Now I'm going to multiply -1/3 times -3 will give us 3/3. Then I'm going to multiply 1/3 times 5 will give us 5/3. If we add them, will give us 8/3. So these are my answers, guys, right here. Okay, that's your X. Now this is the last slide. So for what we just did, how do we apply it in like a real life situation? Here it is, guys. So the budget truck rental charges $19.99 per day plus 59 cents per mile to rent a 12-foot moving truck in Austin, Texas. In 2016, the total bill for your move was $86. The rates for the local moving company were $10 per day and $95 per mile, and the bill for the same trip came out to $94.10. How many miles and how many days was the trip? Okay, so let X be number of days and Y be number of miles. So equation 1, right, is 1999X plus 59Y equals to 86. Equation 2 will be $10 plus 0.95Y equals to 94.10. Right, so by using, because this one you can solve it by here by the addition method, or you can do it, here's another way to do it, right? So it's going to be, this is matrix A, -1999, 0.59, 10, and 0.95. My X will be X times Y equals to 86 and 94.10. Now, if you get the inverse of A, right? You can use a calculator to find the inverse. Hey guys, how you get the inverse for A, guys? Just plug this in the calculator and just hit the inverse key, and it will give you the inverse. Okay, and that'll be the inverse, guys. And then if I multiply it times matrix B, this will be a result, 2 and 78, which means 2 days and 78 miles. That's how long the trip took, was 2 days and 78 miles. Again, guys, all this can be done in the calculator, guys. So that's what I use here is a calculator. Just follow the steps that I show you on the, I think on the slide where it shows how to use the calculator, and you can get it done faster. Anyway, I believe that's it for today, guys. Sorry that I passed a little bit over, like 4 minutes over. Let me go back to the host. That way they can inform you of what's coming up by next week.
Thank you, Mr. Islasi, for your wonderful presentation. We want to remind you all about our previously recorded sessions, which are available on YouTube on the Tejano Virtual Events playlist. This session will be available on the playlist later on today. Also, linked is a short survey to help us improve our Tejano Virtual Event sessions. So please make sure to take a few minutes to fill out that survey. Before you all leave, I want to share the Tejano Virtual Events flyer with the session, or for the sessions that we will be having next week. At 1 p.m. today, we will have the Career and Transfer Services. EPCC will be closed next week because of Good Friday, but we will return on April the 25th, and we will cover the basic matrix operations and using matrix operations with Math 1314. And then we will cover sets with Math 1324. Our 1 p.m. session next week will be on EPCC Honors Program. We thank you all for coming in today, and we do hope that you have a lovely weekend. If you have any questions, please feel free to use the chat or your mic. We hope to see everyone again on April the 24th for our next Happy Math Hour session. Thank you very much. Have a great day.
Thanks, everyone.